Given k sorted arrays of total length n stored on disk, output the sorted union with at most 2 passes. Minimize input-output seeks. We use the external memory model. Data live on disk, read in blocks of size B, memory has size M. Seeks are expensive, sequential scans are cheap. We want mostly sequential reads and writes. A sequential scan is smooth and fast. A random access seek jumps far and costs latency. We minimize jumps and prefer streaming. First method. If M is large enough to hold 1 input buffer per array plus 1 output buffer, we do a single pass k-way merge with a minute heap and suppress duplicates on the fly. Algorithm. Initialize by reading the first block from each array into memory. Insert each current head value into the min heap. Repeatedly extract the minimum head. Output it if it is different from the last output. Then advance only that array to its next value and reinsert. Continue until all inputs are exhausted. Complexity is n log k comparisons in memory. Input-output is a sequential pass. Memory condition for a 1-pass k-way merge is at least k plus 1 buffers, so M must be at least k plus 1 times B. Input-output cost is roughly n over B block reads, and nu over B block writes, where nu is the number of unique outputs. Seeks are about k initial plus a small constant for the output. If k is too large, so that M cannot hold k plus 1 buffers, we minimize seeks with 2 streaming passes. First pass. Partition arrays into groups of at most M over B minus 1 inputs per group. Merge each group sequentially to produce a deduplicated temporary run. Second pass. Merge the G temporary runs with the same method to produce the final union. During pass 1, for group 1 we allocate 1 input buffer per array and 1 output buffer in memory. We stream A, B, and C, write temp 1 sequentially on disk, eliminating duplicates. Then we stream group 2 to write temp 2. Both are sequential with very few seeks. In pass 2, we merge the G temporary runs with 1 input buffer per run, producing the final sorted union. The total input-output volume is about 2n over B reads and 2nu over B writes across both passes, while seeks remain very low because every run is streamed. Correctness hinges on 2 facts. 1. At every step, the minimum current head is the smallest not yet output value, so the merge outputs in non-decreasing order. 2. Keeping the last output value and skipping equals removes duplicates both within and across arrays. In the 2-pass plan, we deduplicate within each temporary run and again across the runs, preserving set semantics. Here is simple pseudocode that is input-output aware. We maintain 1 buffer per active input and 1 output buffer. Each refill and flush is a sequential block operation. Summary. If memory fits k plus 1 buffers, a single pass k-way merge yields minimal seeks and linear I/O. If not, a 2-pass grouping strategy produces nearly sequential access with very few seeks and still only 2 passes of data. Both achieve a sorted union on disk.